All right, so we're continuing on with chapter 2. We're on page 17 in version 7. Control loops. Control loops really mean, why is it a loop? It means because not only are we getting information from the system, but we're sending the information to the system. So a closed loop control is one where we have some feedback for everything that we change, like a temperature system in your house. Your thermostat is a closed loop system because you have got a set point. It can turn on and off your furnace based on how much heat your furnace is pumping into the house. It goes into your thermostat temperature goes up, and it'll turn it off again. So that's considered a closed loop. You've got feedback going into your thermostat. An open loop is one where you don't have feedback. Open loop is one where you basically turn it off and on hoping that you're going to hit the right temperature. A kiln is an example of an open loop. If you're firing a kiln, most of the older kilns, that is, the new ones, have fancy sensors. But the older kilns did not have sensors. And all you did was you basically cycled the power on and off at a certain frequency, hoping that that power cycling on and off at that frequency would keep the temperature at the right level for that oven. You just hoped it worked. And you might have a little cone in there that would melt over and tell you when it, reached the right temperature at the right time. But the fact is, it was pretty loosey-goosey. That's an example of an open loop. There's no feedback. So here it talks about open loops. I should highlight these two things. Closed loop, open loop. I did highlight closed loop, open loop, very important. Okay. So that's just two key concepts. In one case, you have feedback. The other case, you don't. An open loop has no feedback. So the two common control strategies in the real world, if you've got a small controller or a fancy controller, the most common, cheapest, and probably the largest number of control systems out there is simple on-off control. And the one I've been using as example over and over and over, and the one they show here in the closed loop example, and also this one over here in the example of everyone's favorite control system, the one that fills the tank in the back of your toilet. These are both on-off. Why are they on-off? That means your furnace only has two conditions. It's either on or off. Now, there are people out there with fancier furnaces, so let's not talk about those yet. But most furnaces are either on or they're not on. So when it calls for heat, it heats up the house until it reaches the upper limit to the control system, in this case, the thermostat. Then it shuts off the heat. Then the house cools down. When it drops below the limit that we set in the thermostat, it heats the house up again. So your house is constantly cycling between slightly above or slightly below your set point. It's never precisely on set point. Same thing with toilets. Your toilet, when you flush it, empties all the way out. You've got a valve in there. When the toilet float drops down to its lowest level, it opens up the valve. The valve begins pushing water into the tank, and the float slowly goes up. And when it reaches the top point of its travel, it shuts the valve off. And it's done. So it's constantly cycling between lowest and highest level for as long as you're flushing the toilet. Okay? And that's a very common system. Now, this one, I think they meant this illustration for something else, so don't get confused by that. But on-off control, they like to show this diagram for on-off control. The set point is the line here in the middle. This top diagram, the little jaggedy blue line, that line indicates your actual measured temperature of your room. So as you can see, your room temperature is going all the way up, and then down again, and up and down. So your room actually varies a few degrees all day long between your system turning on. So when the thermostat says turn on, in this case, they're showing an AC circuit. It should be a heating circuit. I'm talking heating, guys, not AC. Your heating turns on, and basically it warms up your house. So they did it opposite with the way I'm thinking about, because they showed you an AC system. Great. All right, so it's either on or off. Now, proportional control is a different strategy. It's not necessarily on off, right? Proportional control can be more accurate. So I can use a controller. Let's say my heating system was smart enough so that instead of just either on or off, it can be set at whatever percent heat I want. So my house, when I figured it out, I could set up just enough heat into the house to maintain the temperature that I want precisely without going up and down all the time. That's proportional control. So that's a slightly different thing. We also have other strategies like time proportional on-off control, less common, less important. The last sort of topic in this chapter, it's sort of an oddball in here, talks about calibration. Calibration is a really big deal, and actually calibration, if you guys as instrument techs hear the word calibration, your eyes should light up with dollar signs, because this is where the money's to be made. There's a lot of money to be made in calibration. So read about that. That's important stuff. So I'll just put a dollar sign next to that. So